Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I am your host. And today we are going to be making the enemies in the zombie shooter game, where we don't do any shooting yet, but we do at least have zombies, a little more realistic. As of last week, they had pretty good pathfinding. They walked in a straight line. They were passing a sobriety test. But that's not the zombies that I've come to know and love in movies. So I've got big plans today to add some like staggering, some veering, some lurching, whatever we want to call it, to how the zombies move. Morning, Muaz. Welcome to the stream. All right. Let's get into it. Here we are. This is some code from last week. By the way, folks, as a reminder, this is where you can find the code for every episode. I've just got a branch. Episode 1, 2, 3, 4. Today will be episode 5 for all the streams that have been dedicated to this silly project. And I push them to that public repo so anybody can give this really not that great of code a peek. Morning, Steph. All right. So, yeah, I think we're going to be basically in the zombie file today. So to start, let's build the game and just remind ourselves about all the exciting parts of this. So Flutter run Mac OS. Plan on adding a joystick. Well, I could talk to Khan about that and add her gamepad controller. Yeah, different inputs. I have not yet put a ton of thought into, but playing on a controller actually would be a pretty fun part of the project for sure. All right, zombies, here we go. On the wrong screen, there it is. So the zombie is following me around, and as of last week, we're also rendering this silly blue line that shows what the zombie's path is. And right now it's stuck on the house because, like the person, it has collision detection against surfaces that it can't get around. And we were kind of adding some stuff for the zombie to maybe kind of go around corners. So it doesn't have great pathfinding, but it can like try to get around corners, and then it can also get stuck. And someone in the chat I saw later had a pretty good idea about clearing this obstacle of getting the zombie to not get stuck on corners. And so there's I got to switch to the right file now, don't I? Zombie.dart. Let's make this text big. Get this out of the way. So I had this silly idea of, I knew that, so here's like move along path. So we've got the path to the player, checking for any collisions, unwalkable terrain that is in the way. And then if we do have a collision, we can, how does this work? So if collision does not equal null, we basically find the side of the line that we can't cross, the end of it, the point closest to the player. And if, so these lines are basically the same, except we're using the start and the end. And then I thought, well, maybe we'll just extend this line a little bit so that the zombie goes kind of past the corner. So the idea here, why did the zombie? Oh, tunneling. Right. I switched windows. So the idea, it's going to take a while for the zombie to get back on screen. It knows that it can't get to me directly. And so it just says, here's the red line that it can't pass. And then there's a point on each end of that line, of course. All lines have points on either end. And the zombie says, all right, well, which end of the line is closest to the target? And I'll actually path to that point instead. The problem is it just gets stuck on the line, or it gets stuck on the corner. So I thought, well, maybe I'll make the line a little longer. And so I extended it by 10%. That didn't seem to be enough. And someone was like, you should probably just extend it more than that. So let's check this out real quick. Perform a hot restart. And let's see, does the zombie? Yeah. All right. Oh, it's still kind of stuck, kind of getting around the corner there. Also, it's half in the house sometimes. Let's see if it gets around this corner. No, there's still more to do. I think we'd need to kind of change the angle a little bit, kind of push it off the wall and extend. I think that would do it. But that's not today's challenge. Today's challenge is making the zombies move more realistically. Zombies getting stuck on things is actually kind of realistic. Steph says, when I added the flame joystick to my game, it made it easier to see the whole game. Before, it was dragging the car and old sprite kit game that I'm converting. Interesting. So wait, when you added the joystick support, and I wonder, what did you just use, like a console controller? Made it easier to see the whole game. How did that change your visibility into the game? Did you like zoom out as well? Using keyboard works for desktop app, but I didn't like it for the phone app. Oh, wait, do you mean like an on-screen joystick where you just kind of click and drag like a little button within a circle, and then that kind of gives you a movement vector? Because those things are cool. Does Flame have one of those? That would be incredible. You do mean that. Does Flame also have one of those off the shelf? Wow. I don't know if that last yes was for both or not. But let's start to think about how we're going to handle this. Oh, it does. It's called a joystick. That's why you keep calling it a joystick. That's its name. Great. Let's talk about how to make a zombie kind of stagger about and veer and sway and just in general look like a silly zombie. So I'm going to open up maybe, what was that old draw.google.com? Is that a thing, or is that just slides? I think it might just be slides, basically. Oh, wow. Draw.google.com isn't even a thing anymore. All right, we're going to slides.google.com or slides.new. Okay. So this is kind of how I'm planning on handling this. Let's say we've got a line. So I'm going to draw a line. An arrow. All right, so this is the path that the zombie wants to go on. Let's make this. The line doesn't really need to be bigger. That's our line, right? And if the zombie just perfectly toes the line, then it looks like a tightrope walker and not really a zombie. So this is what I'm imagining. We're basically going to add an arc. We're going to add like an angle that is going to bounce kind of from left to right to influence the path that the zombie is taking. So it'll still calculate the optimal path. And then kind of like an animation controller, like looping around this different, looping between some different numbers, we can calculate some angle like to the left or to the right, basically clockwise or counterclockwise, and we'll apply those modifications to the line as it goes. And I think that'll make the zombie just kind of move around, in this like kind of wandering, looking erratic manner. And then the next thing I want to do after we get that working is like start to stagger its speed, because zombies, I think also, they're kind of like standing there idle until they almost fall forward and catch themselves. And that's, the zombies version of taking a step. And so it's like, and then it steps forward and now, it's one step closer to you. So I don't want the zombies to be moving in a continuous pace anymore. I want them to be kind of like leaning forward and then taking a step, and then leaning forward and taking a step. So that's the goal for today. For the joystick, look in the Flame docs under inputs, other inputs, joystick. Oh, nice. We're going to have to try that out. This sounds less complicated than what I was imagining when I thought you were talking about like adding PlayStation controller support. All right, drawing this arrow didn't really end up being all that valuable. I wonder, is there like an arc? There's got to be an arc, right? Insert, line, curve. You know what? I've actually never learned how to use a curve in these drawing apps. All right, we're done with this. Back to the code. So what I think we want to pick an amount of degrees that the zombie should kind of veer to the left and right. And, I don't really know what is going to make sense here, but maybe we can just start with 45 degrees. So let's have a variable here, static const max veer degrees, and that'll be 45. So this is the distance, or like the angle, the maximum angle to the left and or right the zombie will veer between. I don't know. All right. So next up, we need an amount of time, I think, that the zombie will spend going, how long does it take the zombie? Let's say it starts straight on, and then it veers to the left, and then it veers all the way to the right. And then on its path to veer to the left again, it eventually gets back to center. And I think that makes sense to me as like one full loop. So we need an amount of time for that. And actually, I don't think we'll want that to be the same every frame. We may want to randomize that. So let's even say, let's have like a static const minimum veer duration. And this will actually, we'll just use an integer for milliseconds here. So we'll specify that it's milliseconds, not to be confused with microseconds. So I don't know, 1 second. And then we can have the maximum amount of time that it'll take. So static const maximum veer duration, milliseconds. And then maybe this is, I don't know, 6 seconds. I wonder if this is going to be too dramatic. Maybe we'll try like 3 to 6. Let's see. Okay. So now we need to set the current one. So we need to know the veer duration. So this will be, we'll actually make this one. Should it be a duration, or should it be a double or an int? I don't know. We can start with the duration, veer duration. And I guess this can be late. And then we'll need to know when it started, I'm thinking. So the current, that'll be a date time. That'll also be late. Veer started at. All right, let's see if we can get this working here. So in onload, or I wonder, should we call this in onload or on update? We're going to need a method that uses these two values to set these other two values. And then in on update, we'll use max veer.degrees to go back and forth left and right. So let's see here. Update. Let's try in onload. Maybe we'll have a like set veer method. Okay. And set veer which can just go here, I guess, void set veer. The veer started at will, of course, be now. And the veer duration will be a duration with milliseconds. So if we want to go from the minimum to the maximum, we need like random. Do I already have math imported here? No, but I wonder if random is... No, we have to import math. Okay. Random.nextInt. And we need to give this this takes a minimum and a maximum or something. Oh, just a maximum. Okay, so so if we want to generate a random value between 3,000 and 6,000, we actually want to generate a random value between 0 and 3,000 and then add 3,000 to it. And so that is the maximum minus the minimum plus the minimum. So this would be the maximum veer duration minus the minimum veer duration. And then after we've randomized that, we add the minimum veer duration, I think. Okay, so we have the veer duration. And we know when it started. So now in update, we have this path to player. Let's have another method that's like apply veer or something. Apply veer to path. And this will return another path. But it's not the path to the player. So it's almost like the path to take or the path to move. Yeah, we'll say the path to take. And we'll pass in the path to the player. So now we've got a new method that takes a line and returns a line to path. And this takes a line. We'll just call it path. All right, so we're going to apply the veer to the path. Now, we need to know where we are in this duration. So we have, and we know when we started, we'll know what time it is now, and then we can get our percentage into the duration. So final percent veered. Percentage into the total veer. I wonder if I should have called it like swerve. There's all these synonyms for not going in a straight line. Into the total veer we currently are. And this is the date, time, dot now, dot difference. And that's when it started. And so this is an amount of time. So then we could say like in milliseconds. And we'll divide this by the veer duration in milliseconds. Okay, so we have a percent veered. And eventually this will exceed 1.0. So what we could say is if the percent veered is greater than 1.0, could we just call set veer again? Yeah, I think so. We'll call set veer and, this probably can't be a double anymore or a final, because then we'll have to set it to 0 here. So we've not veered at all at this point. Okay, now we can, so we first calculated the veer and now we can apply it. And so if we think about this, we're going to spend the first quarter of the time going 45 degrees to one side. We'll call it counterclockwise. And then we spend the next 25% coming back to straight. And then we spend the next 25%, so 50 to 75, that goes all the way to the right. And then we spend the final 25% coming back to center. Does that make sense? So we can say if percent veered is less than 0.25, so we're in our opening thing, we're going to the left or counterclockwise or whatever. So let's get an angle, like veer angle degrees, I guess. And this is going to be a double, I presume. So our veer angle double in this case, we can say is our max veer in degrees times the percent veered times 4, right? Because we want to spend 25% of the time covering the entire possible veer to the counterclockwise. And then else if percent veered is less than 0.5. So here it's so let's say we're like 35% of the way through. That would be, we spent 25 going all the way. We've spent 10 going back. That leaves 15 more. So at 35% of the way through, it'll be like we've basically moved 15. And is that we just subtract 25 from it, 35 minus 25. So the percent veered minus 0.25 times, and then we multiply that by 4, and we multiply that by the max veer degrees. I think so. I have no idea if this is right. All right. Else if percent veered is less than 0.75. So here we are going to say veer angle degrees equals it's kind of the same thing. So the first 50 is totally wasted, and then we're going in the other direction. So I think it's going to be the same as this, but the percent veered is minus 50. I mean, 0.5, sorry. And it's got to go in the other direction. So we can just invert the whole thing. All right. Lastly, else if, well, there is no if, it's just else. So here, the veer angle degree equals, it's the same thing we had before, but I guess it's minus 0.75. All right. Yeah, we wasted the whole first 0.75, and then it's however far we've come back. Is that right? Is that going to work? I'm not sure. Wait, why did I type this? Oh, I copied it. What did I mean here? So if I'm at 80, let's say I'm at 90% of the way through the thing, I should be able to calculate we're 10% like to the right of center. So if we're at 90%, well, that's 1 minus the value. 1 minus percent veered times 4 times the veer degrees negative. All right, now we have to return a line. So we have to rotate this line. And well, there's a vector 2. I bet vector 2 has a rotate. Vector, or so on this line class, which is a creation within this project. So line, it's really similar to a vector 2, but a vector 2 always assumes like the start is 0, 0. Whereas this has a non-zero, 0 start. But other than that, it's really just a vector 2 itself. And it has a vector 2 for its start and its end. And somewhere in here, oh yeah, we can find its own, like it as a vector 2 if we normalized its start. And so I think vector 2, this vector 2 class has a rotate method. So we could say line dot rotate. Yep. Nope. What is this? Rotates the vector 2. That's funny. It's auto completing off not even the right thing because I meant to say vector 2. So, oh, it's called path. Path dot vector 2 dot rotate. Now this is going to take radians. So we'll have to give in veer angle degrees times radians to degrees. Nope, degrees to radians. And rotate, look, it returned null, so it's in place. So we can do a cascade and return. Nope, shoot. Why did that not work? Vector 2 can't be, oh, that's right. That's right. Final rotated. We have to turn this back into a line. So what is the line? Return line. Well, the start is the same. It's still the zombie. It's just the end that we're changing. Path dot start. And we need the end of a line is like, oh, a line is a non-normalized vector. So I think we just want path dot start plus rotated. So we return the line from apply veer, and that is path to take. And let's use that instead. Folks, are you ready? Let's restart. And where's the game? Oh, here we go. Okay, it's veering to the left. Now it's veering to the right. Now it reset. Okay, something's not right there. So it veers all the way to the side. The last core. One of these is wrong. This isn't quite right. I want to make sure everything's right with the stream today. 1 second, folks. I suspect there may be some technical difficulties. Yeah, let's go to content. Thanks for bearing with me, folks. Yeah, we did have technical difficulties. The stream was never listed publicly. I'm going to take a second and tweet about the stream. 1 second, folks. Let's see here. Let's quote tweet this. Okay. Apologies. Okay, the stream is public. Let's find out if folks can actually find it. Observable Flutter. Yeah, I'm worried that because we're in the middle of the stream, no one's going to find it. Well, gotta do what we gotta do, I'd say. Well, we're gonna make do. Okay. The VOD will exist in perpetuity. Oh, we've got a joiner. Splash. Welcome. Yeah. The stream was never unlisted, and now we'll pick this up. Folks, welcome. Been going at it for 33 minutes here, written some code, and let's walk everyone through what I've got, because folks will have missed it. But I'm going to try to do this quickly so that we can have, we don't totally bore everybody to death here. This, I think, should be 0.5 minus this, right? And yeah, because it's the same pattern as this one. All right. So team, today we're making the zombie try to move a little more realistically. So let's do a little hot restart. And I want the zombie to kind of sway back and forth and track me a little erratically like a zombie would. So we're going to be moving it. I've got a slightly buggy implementation here that I think I just fixed. So I'm saving the file. It should veer to the right, and now it should veer to the left, and then it should veer clockwise again, and counterclockwise, and clockwise. There we go. All right, so the zombie is looking sillier, but I think its veer is kind of obscured a bit by the fact that it's too fast. So yeah, here now we can see the zombie looking fairly silly. All right, the veer is also going to help it get unstuck. That's kind of cool. All right, let's walk through this code. We got a couple questions here. Can we use Flutter with Unreal Engine? You might be able to embed a Flutter app in an Unreal app using, I don't know, enough knowledge of Flutter to like Dart and C++ bindings and stuff, but I mean, Unreal uses C++, and you wouldn't be able to trivially get that going, I don't think. Recently got into Flutter, loving it so far. Coming from a C# background, Dart's similarity to it and the ability to build apps UI with the principles I know and love is amazing. Welcome them all to both the stream and Flutter. Yeah, I also used a bit of C# before picking up Flutter in a Unity and a Xamarin context, and that ended up leading me to Flutter. Hanif, welcome from Afghanistan. I hope. I don't know how hot it is in Afghanistan this time of year. Afghanistan is in the northern hemisphere, probably, so potentially very hot. I hope you are staying cool. So let's talk about the code that powers this veering that the zombie is doing, because it was all written while the stream was top secret and no one could see it. I've got this idea. I want, imagine a path that the zombie has calculated it should take. If it just moves along that path perfectly, that's not very zombie-like. And better would be to have it kind of approximate that path, but steer a little to the left, steer a little to the right, and, kind of slowly make its way toward the target in a not so precise manner. And I think we could add a curve to this, and that would also be really fun. But we'll worry about that in a minute. So let's say here. Oh yeah, so we've got these different veer degree, or these veering parameters. So one is the maximum amount of degrees, both clockwise and counterclockwise, that the zombie will deviate as it's moving. And I don't know it. 45 might be too much. I just started with 45. And then the style of the veering that I settled on, or that I think I'm going to go with, is to define a single cycle as when the zombie starts actually straight on the line, and a full tilt to the counterclockwise, and then a reset, the full tilt clockwise, and a reset. So this whole thing is one cycle of like swerving or veering for the zombie. Now, it's going to happen. That whole process is going to take between 3 seconds and 6 seconds, as determined by pseudo randomness. And then these are just kind of bookkeeping parameters. We'll know how long is the current one, when did it start, etc. So there's a method called setVeer where we populate these. Folks in the chat, I'm going to respond to stuff in just a second. Welcome, everyone. We've got a setVeer method, and this setVeer method just saves the current time, and it determines the random duration of this one by choosing an amount of milliseconds, which is the maximum minus the minimum. That's our random number, and then we add to that the minimum. So if you wanted a random number between 2 and 4, you could generate a random number between 0 and 2 and add 2 to it, right? So the maximum minus the minimum is your random range, and then you add the minimum to it. So this is going to get us between 3,000 and 6,000 milliseconds. Then in our update method, we're going to not just perfectly walk along the path to the player, but we're going to instead apply this veer, and then we're going to follow that path instead. So that then takes on the path to take parameter name. So applying the veer looks like this. First, we need to take the current time and subtract when this veer started at, convert that to milliseconds, that's a duration, and then divide that by the number of milliseconds of the current veer. I've said veer too many times now. It doesn't sound like a word anymore. That gives us the percentage through this whole counterclockwise, clockwise, back to center, through that whole cycle that we currently are. There's nothing to prevent this from wildly exceeding 100%. So whenever it does pass 100%, we'll just call set veer again. And that will save the new time, get us a new random duration, and then we'll also decide that our veered percentage is 0. Okay. Now, this is the fun part. It's not really very fun. Where we say in this first block here, the first 25% of the veer is to the left. So if we have veered less than 25% of the time that we will spend on this whole swerve, then we'll calculate the degrees we're going to modify our walking path with by taking the percent that we've veered times 4, because we'll want 25% to constitute, all the way to the left. So times 4, and then the max that we can swerve. Then if we're between 25 and 50%, we do it a little differently. We take 0.5, subtract the time that we've currently veered, and then again times 4 and times the thing, times the max. So we've got some more calculations for if we're up to 75%, and then if we're all the way at the end. And then there's a minus sign on these because, whether this is clockwise or counterclockwise for 0 to 50%, we definitely want it to be the other one for 51 to 100%. And then this is our last bit of shenanigans here. The line class that I have added to this project has a vector2 getter again, and vector2s have a rotate function, which is wonderful because I didn't remember how to do this. And we have calculated our veer angle in degrees. All vector methods take radians, so we have to convert those degrees back to radians. We get our rotated vector. I'm sorry for anyone who was actually watching the whole time. You have to hear all this twice. And lines are basically vectors that don't assume a 0, 0 start. So the new path that the zombie takes is, of course, it's still starting where it is, but its end point now is this rotated vector, which is a delta off the start. So this is the path the zombie takes as it's swerving to the left and right. Daria, I am having a great day. Thank you. And you wonder, wouldn't random left to right to left movement make them more zombie-like rather than always following? Yeah, more randomness is definitely better. That's a good idea. Maybe we can work some of that in. So this code is what creates this effect. The zombie tunneled its way to who knows where. So we'll reset and we can see it's starting in one direction. It looks like it starts clockwise. So it starts clockwise and then it comes back to counterclockwise and then it's clockwise. Yeah, we could switch the order. That's actually kind of a fun idea. Let's do that. So let's have so we saw that these positive values are clockwise. So let's have another variable here that'll be late, and we'll call it clockwise veer. That's not how you spell clockwise. Veer first, and it's a Boolean. And in set veer, we'll have clockwise veer first equals. You really shouldn't instantiate tons of random things, but whatever. Next bool. Okay, so we've got our clockwise veer. And for this, we will multiply by -1 at the bottom, if and only if it's clockwise. So a clockwise first is this setting. So here we'd say, oh, how do we want to do this? I guess we could say if not clockwise first, we'll just flip it. So if not clockwise first, then this is times -1. I think that'll work. Let's restart. And then there's some more questions to look at. So it started clockwise first, and then we're looking for it to eventually do the same thing twice. I've not seen it do the same thing twice. It's going through one circle here. Now it's about to reset, and it keeps always going left, then right, then left, then right. Why is that? I thought that was going to work. So we've got clockwise first, and then let's get our degree as well. So this will be like before and after, and we'll just see, like, is this doing what we think it's doing? Is it possible to switch and use relational patterns to calculate veer angle degrees? Maybe. I'm really not good at like trig though. So what's possible for other people is not necessarily possible for me. Well, this is extremely hard to follow. There's too many methods. I mean, too many print statements. But oh wait, it's true every time. Why is it true every time? Oh, it's true every time because we're always getting a random thing, and it's pseudo random, so it's probably returning true every time. You love to see it. Random equals random. Oh boy. Oh boy. This will probably be better. Let's see some falses in there. Looking for a false. Still only trues. Still only trues. No falses. Still only true. This would be a lot of coin flips in a row. Oh, a first false. We actually just had like that many true flips in a row. Now we're getting a bunch of falses. Okay, it switched. But that doesn't seem to be making the thing do left, right, or right. I mean, left twice or right twice. It's still kind of perfectly going left to right every time. When the true and false switches, it should. I'm confused. We do have some ideas in the chat. You should update the value of veer angle degrees in the condition. Am I just? Oh my gosh. Just performing random math. All right, let's get rid of this. Let's get rid of these prints. I think that was the problem. Yep. There we go. We got two rights, two clockwises in a row. Let's see. Okay, it stayed true, so that was correct. Let's see what this one does. Stayed true, so this is correct again. As soon as it switches to false, we should see it. Yeah. All right. Hey, that was a really good idea. I like it. Okay. Get a random number between 0 and 100. Okay, I think this was brainstorming what might have been wrong, but I'm guessing French guy. Welcome, by the way. I was in France a bunch this summer. Lovely. I'm guessing that was before we saw that the problem was missing this. Cyverse, hey guys, first time in this group. Holy smokes. Welcome. I hope you're enjoying yourself as you watch me barely know how to stumble my way through making a video game. Let's close out that, close out all this. All right, we're back. So the next thing that I want to do, and I talked about this before the thing was live, is I want the zombie to move at an irregular pace. Right now it's moving in an irregular path, but I also want its speed to be really staggered. And I was thinking we could, I want it to like move very slowly and then speed up. So, you know, what zombies kind of do often is they almost like lose their balance and then they like take a really sudden step forward. And that's basically how they walk. So they're like not really moving and then they take a sudden step and then they don't move for a little bit again. And then they take a sudden step. And I wanted to try to create that as well. So I think we're going to have a lot of the same variable, a lot of the same stuff that we did for veering. We're going to have for its step speed as well. So let's have an amount of time for each step. And this will have like a minimum and maximum as well. I don't think this 3 to 6 second. Oh, how should we call this? Maybe stagger or lurch. Zombies kind of lurch forward. Yeah, let's do lurch. Almost typed lunge. So 3 to 6 seconds, that feels like it's going to be really, really slow. Let's try like half a second to 1 second. I'm not sure. And next, we've got, we need to know, how long is this one going to take? So this is the lurch duration. And then we need to know the late date time for lurch started at. And I think we're good there. Okay. So in onload, let's have another method, set lurch. I'm just going to follow this same pattern. Worked pretty well. Void set lurch. So this is going to make the zombie kind of move in a really staggered way. So we need to say lurch started at equals date time dot now. Then lurch duration equals, and I'm just going to copy all of this. All right, so we have our maximum lurch duration goes here, and our minimum lurch duration goes in these two spots. Very good. All right. All right, I think we're good there. Now we just need to figure out the correct way to apply it. And this is really just all about the speed of the zombie. So we could lengthen or shorten path to take. That's one option. Can be. A regular viewer says zombies form hordes. They do. So can you make a zombie be drawn to the nearest play or zombie? Something or zombie. Then you can get some really interesting horde behavior. Yeah. So I think that would be very fun. Working on what the zombies do when they don't find the player. That's absolutely what I want to do after getting this lurching behavior going. That's such a fun idea. I hadn't necessarily thought of attracting zombies to each other. I was thinking about having them just wander aimlessly, but congregating would be interesting. All right. So we can either lengthen or shorten path to take that we pass to move along path, or I guess we could just modify the speed. I'm not really sure what's better. I think I'm just going to modify the speed. So let's have a method. This is going to return a double, and it's apply lurch, and it'll take the old speed. Okay, and we can probably steal some code from apply veer. Where is that? I collapsed it. Yeah, so we need to know like our percent lurched. But I have a cool trick up my sleeve for this. So this is going to be percent lurched, and it's the lurch started at and the lurch duration. Okay, so we've got our percent lurched. And then we need to do definitely the same thing with the, if it's more than 100%, reset stuff. So veered here becomes lurched and set lurch. Okay. Now, I think I have a fun idea. You know how with animation controllers, you can, with animation controllers, you can pass in a curve, and then your animation will, happen on that curve, which is a ease in, ease out, all this stuff. Really, really nice for natural looking animations. You can just do that off the curve class as well. They have a transform method. So for apply lurch, what I think we can do here is our percent lurched can include the curves class. Let's just bring it in from animation, I guess. And we want like a sharp end, right? The zombie kind of spends the whole time like leaning forward, and then it steps forward and catches itself. So most of the time it's doing nothing, and then it steps forward. So that would, I think, be like in the ease in family, because it would easing in on the motion and then hitting it hard at the end. So ease in, and then there's a transform method, and we just give it a double. Look at that. And this, I think we can multiply by the speed. So this is going to be a huge dampener on the speed of the zombie, and we may need to increase the speed of the zombie. But let's check this out. Looking good. Oh, it's not looking good. Something broke. What's the problem here? Interesting. Non-null must be returned. Oh, apply lurch. Didn't we return? Oh, I didn't save the file. How's everybody doing today? All right, so we're seeing it lurching, and it's that's not the most satisfying. So I'm not really sure. I don't know what will make this look better. I mean, I think it does need to move faster overall. It's not too bad, actually. It's kind of cool. I wonder if we can make it even more staggered, though. Let's try, let's do Flutter curves. So I'm just pulling up the documentation here. Make this bigger. So these are all the curves that are available to us. And I think we want the one that is like the most dramatic hockey stick possible. So yeah, okay. So here's all these ease ins. And I guess ease in exponential is going to, by definition, be is going to be the one that is most intense. So ease in expo. Let's try that. Ease in expo. Refresh. So this slowed it down even more, but it's definitely more it's kind of more jerky, right? I think it needs to take more steps and still take them overall faster. So let's double their speed, and maybe this can be like 300 to 800 or something. So a few more steps and a little faster each step. So still too slow overall, like dramatically too slow. Yeah, way too slow. Let's double their speed. And you know what? I think the expo is too much. I think I'm going to go back to just ease in. Let's refresh. So they're a little faster. Oh, now this is starting to feel pretty intimidating. Okay. All right. I think I like it. Anyone have any ideas on how we might make this even better? Oh, maybe rotate the zombie when lurching. Oh, yeah. I have nothing so far around, I'm just not changing the animation at all. Not changing it, or the sprite, sorry. The sprite never changes, which is not great. That will certainly be required to make any of this movement feel realistic. Obviously, right now they're just terribly skating around. But in terms of rotating it, that's an interesting thought. It's like, because we only have strict top down. Yeah, we could. Yeah, rotating it would probably work for the veering. And maybe that's what you meant. Maybe we could try that. Oh, lurching is too regular. Okay. Yeah. Say more about this. What do you like? Bigger variations in how long they take, maybe different curves even. Oh, yeah. Picking a random curve could be pretty interesting. So where did that documentation go? Did I close it? No, it's here. We could pick a handful of curves and that's actually quite nice. Yeah. Oh, I like that. Okay, let's pick a couple of curves, and every time we will randomize the curves. So final curves equals curve, and one of them will be curve dot ease in. We already saw that one's pretty good. Okay. Should this be curves? No. Wait, why does this have to be curve and this has to be curves? Well, I know why this has to be curves, because it has to be, but I'm surprised we can't put curves here. What is the error for we do this? Cubic can't be assigned to list of type curves. There is some wild type shenanigans going on with this. So let's pick another one. I'm going to put that on a different window because that's how my brain works. So, maybe like even ease in back, kind of stagger back a little bit at first, maybe, or at some point. And then we could have some that are front loaded and maybe some that are middle loaded. So ease out. Let's do an ease in out. Yeah. Ease in out, sine, ease in out, quad. Well, these are really similar. We'll just do ease in out. This is a pretty good idea. Yeah, random curve. You had that idea as well. Nice, Andy. This one's kind of wild. Ease in, out, back. And lastly, we need a single curve. So this will be late curve, lurch curve. Okay. Oh, right. Of course, curves is the container. This is just like icons. How silly. Yeah. Ease in is a curve. Curves is just the bucket of curve objects. Duh. Anyway, so we need our current lurch curve, which will set in, of course, set lurch. So down here, we'll say lurch curve equals curves dot shuffle dot first. What's the problem? Now, a list curve can't be assigned to a variable of type curve. Dot first. Yeah, that's a getter, not a value of type list curve can't be assigned. So shuffle normally returns void. Is this like, do I have to do this on 2 lines? I don't really want to do it on 2 lines. Why do I have to do this on 2 lines? That's so weird. All right. Also potentially more random time. All right. So more randomness, you're thinking. All right, let's do this. So we've got different curves. Yeah, this, oh, nice. This already does feel way more unpredictable, which I guess you could also say is way less predictable. Nice. Good ideas. This is a realistic zombie, if I've ever seen one. Let me tell you what. All the zombies that I've met in real life, this is how they behave. The distance they travel random. So that is kind of random based on the time that is chosen, because the time that is chosen is going to, if it's a lot of time that's chosen, then down in apply lurch, it will take more time to reach 100% or 99% is as high as we can actually get. And if it takes more time to reach 99%, then we will often not, we'll spend more time moving less distance. So it's randomizing the distance that they move. All right. So apparently double cascade. I thought I tried double cascade. Curves dot shuffle dot first. So this compiles. Yeah. So there's something that it doesn't like about this. And it says that it can't put a list on a variable of type curve. I don't know why. Weird. Yeah, we could create an extension. A lot of things we could do, but I think I'm just going to go with this for now. Once you have several zombies, they can each have a random curve and rarely change. Might be less chaotic, but then they behave different from each other. Okay, that's another good idea. I've screwed this up. I got rid of the shuffle entirely. And then someone pointed out that we could just take a random thing, which I think is a better idea. Oh, what is the way to get a random element? Oh, maybe there is no way to get a random element. Shuffling does feel heavy-handed for just taking a random thing. Like we could get a random number and grab that index. A lot of things we could do. You know what? We're bike shedding a little bit. I'm shuffling the list. Okay. So let's get some more zombies. I think that's what we need. So in our world, we add a single zombie. Oh, I'm also going to add, let's add a debug parameter, and that'll be whether or not they draw their line. So bool debug. And down in the hole, where do we even draw the line? Well, I think it added its own method. Oops. Debug. Yeah, debug pathfinding. Look at me. So if not debug, then return. Wonderful. And I think I set it to false. Yeah. So when we add more zombies, we won't just have a storm of blue lines on the screen. All right. Let's make some more zombies. 4x. No, I want to zombie. How many do we want to add? Let's add like 15 zombies to the area. Zombies to add 15. While counter less than zombies to add. And let's add a zombie in a different place every time. And for now, I'm just going to add this, but this isn't really the best because we would certainly need to keep track of it. So we need kind of some random coordinates in these top squares. And I would need to make sure that none of them appear. None of them are in the house. I'm not going to worry about that right now. So the X coordinate, we put it at 14. So let's pick like random numbers between 0 and 20. So our X coordinate is going to be random. Let's give the world a random thing. And we have to import math. So this is random.nextInt, just 20. We're going to do, but then let's bring them in from the actual border of the game. Same for Y. So this now becomes world tile size times X and world tile size times Y. And we've added these zombies. Let's see what we got. Oh, infinite loop is what we got. Counter plus plus. Let's try it again. I think it might still be really upset with me from adding a quintillion zombies earlier. Yeah, I definitely want to add zombie spawn points. Places where zombies keep coming from. Doors of buildings. Get out of cave. You know, something like that. All right, so they're coming in hot here. They kind of look like a bunch of birds. Yeah, I'm really getting like a flock of pigeon vibes. Is anyone else getting that? Oh, look at them. They all dodged the tree, though. None of them walked through the tree. That was pretty cool to watch. So here they should all kind of go around the house. Oh, they're taking different paths. Not bad. Not bad. Now, if we could cast a fireball or we had a gun or something like that to fight back against these things, then we might have a game on our hands. And this speed difference feels pretty good to me. I'm curious what you all think. You can kind of like allow them to form up into a flock, or we could outrun them if we needed to kind of reset our our health or our reload our weapon or something. And right now these zombies don't have a maximum follow distance. They never lose interest, but I do want to add that as well. That seems pretty good. I think the way the zombies are moving isn't too bad. Could be good to actually add some animation on to like actually use to different sprites as they're walking. I think I don't really know much about that. I don't know the finer points of defining how quickly they need to switch and all this kind of stuff. Super zombies we want? Yeah, we definitely need super zombies. All right, let's think about what to do next here. We've had a pretty successful... Oh, I do want the zombies to stop following after a certain distance. And maybe they shouldn't be able to share the same space. Except that then gets into actual flocking algorithms, which I have not looked up and don't know anything about. So I'm not prepared to make the zombies unable to share the same space yet. Yeah, what was the thing I was just saying? Oh yeah, like a max distance. So I think they can have two modes. One where they are tracking the player and one where they're wandering. And in the update method is where I think we would handle this. So path to player, we could have a maximum follow distance. So final maximum follow distance, and this is a double, is the world tile size times, I don't know, 10 squares or something. So every time, if the path to the player dot length, I think we have, path to player dot length is greater than the max follow distance, then we're going to just totally do something else. But if it's within the max follow distance, then we're going to actually follow the player. It's loaded. Asks how many videos are there for this game? This is just the 5th one. So you haven't missed that much. Yeah, if we here have in that update method, this code here, this would be like the wander state or something. And someone had mentioned making them like seek each other and whatnot. I think that's a pretty interesting idea. They would basically all just congregate on the same spot though. So again, that'll basically require some flocking algorithms that I would probably want to research off stream and show up knowing how to operate. So maybe for now, they can just pick a random direction. And for that, every frame, you don't want to like pick a new random number between 0 and 360 because they would just like jitter essentially in the same spot and it would be terrible. So again, you kind of want a line that they're following. You could pick a random line to start and then figure out a way to kind of left and right veer it again. And then maybe also when they're not following the player, they move even slower. So Forge 2D for physics is part of it, but there's an issue can arise where, let's say you have a horde of zombies and they all need to take a step forward. Only the zombies in the front will naturally understand that they can take a step forward because in front of them is open terrain. But the zombies behind them would be like, I can't walk forward. And if I'm in a tight pack, I actually can't really walk anywhere. What the zombies will all do, of course, once you have a good flocking algorithm, is that just all march forward. But until you kind of tackle the idea of, having zombies understand that, well, the zombie in front of me is walking forward, so I can walk forward. And then you have to move over them in like the correct direction. If they're walking to the left, you have to start on the left and calculate their movement and then move to the right. And then those zombies will say like, oh, well, I'm about to hit a zombie, but I'll check its movement vector. What's it doing? And then I can move. And, maybe it's honestly as simple as that, but you'd also have to detect where the flock is. Or maybe you just move if they're moving. I don't know. I think it's really tricky. There's a lot of complexity to it, and flocking algorithms have figured it out, but I have not looked at flocking algorithms. So I'm unprepared for that. But yeah, physically having them not share a space is one part of the problem. That one's not as bad. But then having them do something other than like all get in gridlock, it's like just rush hour traffic for zombies everywhere as soon as they bunch up at all. That's the interesting part. All right, so let's get a wandering state for the zombies. I think that'll be pretty fun. And then maybe that'll conclude today. So if the player is too far away, then let's just call a wander method. And down here, this can be follow player. So void follow player. It's probably going to have to take a parameter that I'm not yet passing. Yep. The path to the player, naturally. And then you take a line, path to player. Okay. Oh, and you need the DT. The delta time. All right. Now, the wander method. It'll probably also need the DT at some point. Oh, that's not how you write code. Okay. So if we're wandering, we kind of need to know what our wander path is. And this is going to be a vector 2 because it's just the path from the zombie's current location. And it's going to be nullable because when the zombie is following the player, there is no such path. So it's a nullable vector 2, and this is the wander path. Nullable. Turns out if you just say stuff but don't type it, then it's not real. So the wander path can equal get random wander path. So if it's set, we keep it. If it's not set, which it won't be anytime we follow the player, then we'll call this get random wander path method, and that will set the wander path. So here we want, I guess we can basically take a vector that will go to 1, 0, and rotate it a random amount of degrees times degrees to radians. We'll return this. And then we just need to say degrees is a double. No, it can be an int. That's fine. That our initial degrees is random next int 360. Oh, Victor 2. All right, so we pick a random amount of degrees, and then we take a standard vector, which is pointing all straight to the right. So that's 0 degrees, if I remember right. I think straight to the right is 0 degrees. And then we rotate it the random number of things. And that's our first path. That the zombie will go on. Now we're going to slowly deviate this again. And I think I don't want this to necessarily always go back and forth. Like this should be able to wander in circles. So how do we want to do this? maybe we can say, we can keep track of how much we're turning every turn. We can have like a wander arc that's another amount of degrees. And we will update that by like +1 or -1 every turn. That'll again still average out to just going straight. We're going to need ideas like I'm veering to the left for a while. I'm veering to the right for a while. Also, we are eventually going to move along the path. So that'll be this. Oh, you need a line? Why did I do that? Why am I not having this be a vector? Path to player dot vector 2. Yeah, man, boy, this really should have been a Ooh, apply lurch in this method is also not very good now, is it? We should have applied this to the delta time. We absolutely should have applied apply lurch to the delta time. All right, we've got some refactoring to do. This code is getting not good. So I'm pausing, working on the wandering, and I'm going to go back and clean up this lurching code that I had. This isn't going to work. So let's have a single method that is like apply movement. So void apply movement. And this is going to take a vector 2 because that's what it should actually be. And this is the movement. And that is going to use this code. Okay, apply movement. And we haven't moved at all yet. So we can, I think, get the original position in here. All right, now this does need the delta t. And let's not apply lurch to this anymore. That was not good. Maybe we apply it to either the movement vector or the delta time that we pass in, one of those things. So here we're now going to call apply movement. And the movement that we pass in is this. And then we owe it the delta t. And this is just a multiplier on a double. So I think we can say apply lurch to the delta time. And we get rid of all of this. This is better. Okay. Now, where was the actual update method? Apply, where are you, update method? Wander, update. Here we go. Okay. This is already so much better. So move along path isn't what we would call anymore. Now it would be apply movement, and it would be the wander path dot vector 2. Oh, it is a vector 2. Okay, great. I haven't looked at chat in quite a long time. I suggest each zombie having a zombie state, an enum of wander or chase. Once that is done, you can easily extend to more complicated states such as follow zombie or sleep. That's quite good. That is good. Add a shift walk so that zombies won't detect you because they're blind. Yeah, I do want to just turn off their ability to follow so we can walk around and watch them wander. Going back to the zombie enum state, you could have a random path like you did, but with a hidden bias towards the player. So if you stand in a place, they will eventually find you. Oh, that's actually interesting. Yeah, see, gosh, this is the fun part of game development. Yeah, sure. Let's do the zombie state. Enum zombie state, and this will be wander and follow. No, chase is better. It's just more evocative. So wander and chase, and so they'll have a state, And this will start as zombie state dot wander. All right, so now in the update method, let's have a update state function, which is basically going to do this stuff. So this is void update state. And all we really do here is we say not wander anymore, but state equals zombie state dot wander, and state equals zombie state dot follow chase. All right. Now here we can use some Dart3 stuff, and we'll switch on state, and we'll check the case of zombie state dot follow, no, wander. And in this case, we will call wander with DT. And if we have the case of zombie state dot chase, we can call chase, and we'll pass in the DT. Oh, that's pretty good. All right, so wander and then follow player. This now just becomes chase. And we pass in the path to the player in the DT. All right, this is a lot better. And yeah, and in chase, we zero out the wander path. So when we get back to wander, first time this is called, we'll update the wander path. This will be random. And then we want to still figure out the, yeah, there's a good idea, Ken. We can figure out a way for it to kind of spend some time veering to the left. I mean, maybe it's kind of the same as the swerve thing, except no, it's different. I mean, that is just totally left, right. Yeah, I wonder if we can say, oh, I wonder what if just like every 5 seconds we pick a new random. I'll close this stuff. So when we enter wander, let's also have a like wander delta that is going to equal. So this is going to be an amount of degrees between -10 and 10. So random dot. Oh, I should put this up top in like the definition. Static const minimum wander delta. So this would be it can go 10 degrees counterclockwise or clockwise or whatever. And then 10 degrees is its maximum. I wish there was like a between method. Wander delta, apply movement. That's not what we wanted. This is random dot next int, and we're going from maximum wander delta, which is 10. And I need to subtract the minimum, right? So that would give us 20, which is what I want. So it's 0 to 20, and then we add the -10, taking us from -10 to 10. All right, so we have our wander delta. And so I think every turn we wander delta. What's the problem? Int can't be assigned to type debu. Okay, fine. Oh, and it's, yeah, we'll specify that it's degrees. Okay. So we have our wander line. And now we're going to add wander path dot rotate by wandered. Oh, and then this is wander delta degrees. Can't be null. What did I make this? I made it late. Yeah, there's a couple more state changes I need to make here. The state machine is getting a little unruly. It's really not very good. There's some cleanup to do. So wander path dot rotate, and this we pass in this times degrees to radians. Wander path. Okay. And now our wander path is like, yeah, it's veering to the side. We'll also add we can add a wander start where we update. No. I did this last time too. So if this doesn't equal null, we know we're getting into the wander state. Yeah, this is really just not good code right now. But we're spitballing and then we clean it up later, which we might not have time for on this stream. So then we can say our wander started at datetime.now. Save this variable. And what I want to do here is, I should have set wander. That's what I was doing before. That's why those other things were less dirty. I had set and apply were different. Yeah, that's right. So when we set our state to wander, first we can check if state does not equal wander. Here we'll have a set state to wander method. That's better. Void set state to wander. And this will set the state to wander, and it will initialize this code, initialize the variables that we need, and it will initialize the wander degrees. Great. Now for wander, we take our wander path, we rotate it, we save that to wander path because we want to keep rotating. And we apply the movement. And then the deal is if, let's say every, I want to alter the degrees. Well, actually, let's just run it right now. I think what's going to happen is they're just going to keep like veering forever. And I want to reset that. So I want to use this wander started at to every now and then update the delta. So it's like, oh, I'm veering to the left 10 degrees, but I've done that for 3 seconds. So now I get a new delta and, it's something different. Or maybe we would need to redo the wander path. I don't know. Let's just see what they're doing. See how it looks. So this all starts in update. Whether or not they can, update state. So this was it. So we never want to put them in chase. That's the point here. They're never going into chase. So this is if true or, true or, right? They'll always be wandering. Then we have some dead code. So they should not follow us anymore after I fix this bug. Null check operator used on thingy thing, line 123. Okay, which one? So wander path should get set. Oh, we're going to have to set state to wander in. I know what the problem was. We need to do this in onload. And now there's no point in having a default state. This can be late. Okay, doesn't look like it's crashing. All right, they're wandering in a very silly way because they're all just going in circles. Some of them have tighter circles. Some of them have wider circles, but they're moving in totally fixed circles. So -10 to 10, I think, is too much. It should probably be like -3 to 3. And then we definitely need to start resetting this pretty regularly. And then I think we'll be in a good spot here. So -3 to 3. Are those the zombies you recognize from The Last of Us, Diogo? So -3 to 3. And we really need to reset their wander periodically. So let's think about how to do this. In the wander method, we can maybe say if wander, and let's get a duration for like wander length. And this is amount of time to follow a given wander path before resetting. So wander length is now another variable that we need to update in set state to wander. So wander length will be a duration with milliseconds. I don't really know. I'm just going to put it at 1.5 seconds for now. We can randomize this later. So wander length. So now we'll say if datetime.now.difference wander started at is greater than wander length, then set state to wander again, and we'll just get a new wander path. And this isn't going to be too good because this new wander path could be like 180 degrees different from the old one. So we'll want to like have some kind of something better than what I've got right now. Yep. I've seen some 180 movement here. It looked really, really, really silly. They're also just way too fast. Oh yeah, I meant in wander for apply movement to like slow them down like crazy because they're just okay. That's too much. So let's divide it by 4, maybe quarter speed. It seems slightly too fast. 6. Slightly too slow. 5. This is precise, folks. All right, we've got some wandering zombies. They're not like lurching. We'd want them to do that. So apply movement here. Oh, here we could say apply lurch. Oops. Okay, and the lurching was a huge damper on their speed. So now we probably speed them up a little bit. All right, we have some just kind of like stumbling zombies. That's cool. Could be so fun if they don't see you if you walk behind them. You could sneak past a wandering zombie, but hard to sneak past 5. I love it. Yeah, that's so great. We can have like a crouch and move slowly mode. Of course, it'll be tricky to visually indicate crouching with these limited assets, but we can do our best. Yeah, you could crouch and move slowly and reduce the ability for them to hear you. So, maybe they can hear all around them, they can see in front of them. And if you move slowly, you make less sound, so it shrinks the radius in which they can hear you. But I think these are some just kind of staggering zombies, huh? This isn't bad. None of them are following us because we're pretending we're outside of all of their range. But this feels good to me, honestly. I'm actually quite happy with this. All right. Being quite happy with something is a great time to call it. I will just remove this little dead code check. And yeah. All right. The zombie class is taking on a lot of logic here, but it's not terrible code. I think there's definitely some, we could have an extension method on random. So we could just pass it like a minimum and a maximum, and it could do this whole max minus min plus min shenanigans. That would make it a lot easier to do stuff. Like I'd honestly like the wander length to also be randomized. I think there's the idea of having a zombie state and doing this so much better. There's probably still further refinements we could make there. And how about these Dart 3 switch cases, right? Actually, I think none of this relates to Dart 3. You could always switch on an enum, but in general, this isn't a thing that I thought about a ton until Dart 3 brought it to like other classes and other types as well. So pretty cool. All right, folks, that is going to do it for today. The zombies are coming along. Just remember, I'm going to push the code up to this repository. This is where you can find all of my chicken scratches. If for some reason you want to read them at your own pace, they will be there. There's a branch for every episode that has been about this project. Folks, until next week, have a great one. And I'll see you again on Observable Flutter.